All right, welcome to the conference on graphing square roots and cube roots. This is going to be a two-part video. In part one, we're going to look at graphing the square root, and in part two, the cube root. Now, there's some information on here that's very important to doing well in your test. And on Blackboard, there is a worksheet you can print out to copy the notes and then to complete some problems afterwards. So please make sure you have those ready to go and fill out the notes as we go through this presentation. All right, so part one again is graphing square roots. So let's look at the parent function of the square root. The first thing I'd like to take note of is that f of x equals the square root of x is the same thing as y equals the square root of x, since y equals f of x. All right, so don't let the functional notation throw you off. Next thing we want to take a look at are what are the possible values of x. So in other words, where do we start? Well, I think a natural place to start would be 0. The square root of 0 is 0. Okay, and that's actually a good point. We'll go ahead and mark that over here. Another good point, the square root of 1 is 1. Okay, so 1, 1 is a good point. And if we were to start plotting these, we might think that we have a line going on. But this is not a line, and we can verify that. Let's go ahead and pull up our calculator. All right, so if I did, for example, the square root of 2 is 1.41. Actually, I can write that a little better. Okay, 1.41. There we go. And then square root of 3 is 1.7, or was it 73? Okay. Now, so again, obviously, if you just plotted these 2 points, you might think it's a line, but as we plot a couple more, we can see it's not. So we want to think about what's a good point. Since we're dealing with the square root function, if we pick perfect squares, we'll get integers, and they're going to be a lot easier to plot. So we had 0 and 1 already. What's our next perfect square? So 2 squared is 4. So the square root of 4 is 2. This is a good point. And then the square root of 9 is 3. So here we go. We have some good points, and we can go ahead and plot the rest of these. So 4, 2, and 9, 3. Okay, and what we can see is we have let's pick another color, a nice little curve going here. All right, so let's take a look at domain. Again, this was on the xy plane, so we want real solutions. So note that the square root of -1 is I. Okay, so you can see from our graph, we don't have any negative numbers. So we want our domain to be x greater than or equal to 0. In general, you always take what's under the radical and set it greater than or equal to 0. And our range, you can see we start at 0 and we go up to infinity. So our range is also y greater or equal to 0. Okay, so this is our parent graph, and this is our parent t-chart, and we want to keep that in mind. And what we're going to do over the next couple of slides is look at what happens if we shift it, the parent graph, left, right, or up and down. So the first thing we're going to look at is shifts left and right of the parent function. Notice this takes place when there's a change underneath the radical. So in our function up here, it says f of x equals the square root of x minus h. So this is going to be a shift h units. So keep in mind there is a minus sign in the formula, so that if I were to try to line this up, x minus h, it's clear to see that h is strictly 2, which is going to be a shift 2 units to the right. All right, so we found some good points for our parent graph. And what we could do is we could set what's underneath the radical equal to these good points. In this case, we'll get x equals 2. So 2 would be our first good point. Looking at the domain, again, if I take what's under the radical and say greater or equal to 0, I get x greater or equal to 2. Now this is a shift to the right 2 units, so the y value is not going to change. We'll verify this once we actually plot it. That's going to stay y greater or equal to 0. Alright, so if we find f of 2 to find our y value, it's going to be the square root of 2 minus 2, which is going to be the square root of 0, which is just 0. Okay, so let's take note. If we look at our first point in our parent graph. The y column stayed the same, 0, and our x column, 2 units were added to 0 to get 2. All right, let's go ahead and look at one more point before we make any conclusions. Let's go ahead and erase this. Okay. So our next point was 1, so we'll set x minus 2 equal to 1. And if I add 2 to both sides, I get x equals to 3. So I think 3 is my next good point for x. And f of 3 here is going to be the square root of 3 minus 2, which equals the square root of 1, which equals 1. Okay, so again, if I look at my y parent graph, it's exactly the same. This makes sense. It didn't shift up and down at all. So this is actually going to be the same as this whole column. And then on my x values, again, I added 2 to 1 and got 3. So if I add 2 to 4, I should get 6. And if I add 2 to 9, I should get 11. All right, so let's go ahead and plot those points. So we have 2, 0, 3, 1, 6, 2, and 11, 3. So I imagine it's out there. Okay, and we can see if we were to look at our parent graph, that this was a shift. Let's go ahead and 2 units to the right. Okay, we'll take a look at another method in our shift to the left. So here, again, under the radical, we have x plus 2. Well, our formula has x minus h, so we got to rewrite this with subtraction, so it'd be x minus the negative 2. Okay, so here we can see the h is negative 2, so it's going to be a shift 2 units to the left. All right, now, if we look at our points on our parent graph, we have 0, 0, 1, 1, 4, 2, and 9, 3. Okay, if I were to take all those points and move them 2 over to the left, I would get this set of points right here, which I'm claiming is going to be my shift 2 units to the left. But let's verify this. First of all, let's look at the t-chart. So again, we're not going up or down. So my claim is that this whole column is going to be copied over here. Okay, and now I'm claiming we're moving to the left. So if I were to subtract 2 from each of my x's, I should get negative 2, negative 1, 2, and 7. So let's first verify that these points are our points on our graph. So our first one is negative 2, 0. Check. Negative 1, 1. Check. 2, 2. Check. And 7, 3. Check. So that did work. Let's go ahead one more time just to verify. Let's pick a point like 7, 3. Okay. If I were to let, for example, f of 7, that would be the square root of 7 plus 2, which would be the square root of 9, which would be 3. So that does check out. So this idea of just moving the points works. It also works on copying over the parent graph column and subtracting each 2 units from each thing in the x column. So our domain here, again, you take what's under the radical, x plus 2 greater or equal to 0. So x has to be greater or equal to negative 2. Okay, so that works. And the range, again, is still going to be y greater or equal to 0, since we did not move it up or down. Okay, so that shifts left or right. Let's take a look at a shift up or down. This is where a shift up or down will occur if a change takes place outside the radical. So you notice that under the radical, we still have the square root of x. So this is very similar to our parent graph. So our domain is still going to be x greater or equal to 0. Okay, and you'll notice that we'll have all our same points for our x values, because we're going to be taking the square root of x. And now what we're going to do is we're going to be adding to each one. So in this example, we're adding 3. So k equals 3, which means this is going to be a shift up 3 units. Okay, so let's calculate the first 2, and then we'll just see if we can make the relationship. So f of 0 is going to be the square root of 0 plus 3, which is going to be 0 plus 3, which is going to equal 3. Okay. So let's notice that this is 3 more than 0. And f of 1 is going to be the square root of 1 plus 3. It's going to be 1 plus 3. It's going to equal 4. Okay, let's also note that that's 3 more. So I think we can see what's going to happen. We're going to add 3 to 2 and get 5. Add 3 to 3 and get 6. So I have my new points here. 0, 3, 1, 4, 4, 5, and 9, 6. Okay, so we get this nice shift 3 units up. Again, if we compare this to our parent graph, you can see it's strictly a shift 3 units up. Alright, so the next one, as you probably guessed, is going to be a shift, oh, wrong way. Alright, 3 units down, right? So here K is a negative 3. So it's going to be down 3 units. So as we saw earlier, if I looked at my parent graph points first, that I could actually take each one of these and move them down 3, right? This would be my new graph. See how easy that was? So again, we did not move left or right, so our x column should be the same. And what did I do? I subtracted 3 from all my y values. Get a little clear. Okay, so I should get negative 3, negative 2, negative 1, and 0. And again, we'll just take a time to make sure these points are right. So as I look at my first one, 0, negative 3, that sure is right there. 1, negative 2, 4, negative 1, and then 9, 0. Okay. And again, if I take a look at one point just to double check, f of 4, well, that's going to be square root of 4 minus 3, which is going to be 2 minus 3, which would be minus 1. So that does match up. So there you have it. Well, let's take a look at our domain. Our domain doesn't change from our parent graph since we do not move left or right. So this is still going to be x greater or equal to 0. And our range now did change, right? So it's going to be y greater or equal to negative 3. Let's just double check. Here our range is going to be y greater or equal to 3 since we shifted everything up 3. And that's it. So that's the end of part 1. Again, make sure you complete your worksheet and see your instructor. Thanks.